let's talk about addition, subtraction with fractions. If you want to take a minute to read over the blueprint here, this has got some helpful information and instructions. Okay, so let's move on. So I'm going to pick one of the addition and one of the subtraction. Whenever we add or subtract fractions, you must have a common denominator, and you want to pick the least common denominator, the smallest number that all the denominators will go into. And it might not be the same amount of time, but they will all go into that number. So if you need a refresher on this, go check out the video about least common multiple, which is LCM. Okay, solving for the LCM. All right. So let's just pick, try and find one that's not so obvious. Let's pick V. If you notice, I get 7 20s plus 11 15s. And if it's not obvious to you what to pick here, go ahead and break it down. So take the 20, set it in prime factors. Well, I know it's 2 times 10. And I know 2 times 10 gives me 10 is going to be 2 times 5, right? So I can write that as 2 squared because there's 2 sets of 2's here times that 5. And that 15 is going to be 3 times 5. Now I'm going to write each base once. And I see I have a 2, I have a 3, and I have a 5. I'm going to pick the 2 with the highest power, which is 2. Let's pick the 3 with the highest power and the 5, which they're all to the first. So 2 squared is 4. Then 4 times 3 is 12. 12 times 5 is 60. So my least common denominator is 60. So I'm going to take this and set it up to where I have 60 in the denominator. So what I need to do is say 20 times what will give me 60? Well, it's 3. What I do to one part, I must do to the other. So now let's come over to this next fraction. 15 times what will give me 60? And if you're not sure, you can divide 60 by 15, but it's 4. So 4 times 15. Now, whatever I did to the denominator to get the 60, I must do to the numerator. I'm going to rewrite this. I got 3 times 7 plus that 4 times 11 all over 60. 3 times 7 is 21 plus 4 times 11 is 44 over 60. And now I got 21 plus 44 gives me 65 over 60. Oh, and this will reduce because it ends in 5 and 0. So I know it'll reduce by 5. So 5 goes into 65 13 times. So I got 5 times 13. And then 5 goes into 60 12 times. And the 5's reduce to 1, leaving me with 13 12s. This is the simplest form because 13's prime. All right. I'm going to do this one right here, but I'm going to write it. I'm going to scroll down and write it on this other part right quick. So I'm going to write the 12 over 1 minus the 7/9. And in order to subtract, I must have the least common denominator. I did say greatest common denominator, but we really want the least common denominator because you want the smallest number. If you get the greater number, guys, you're going to end up having to reduce in the end. So just double check. You may reduce anyways, but if you use the greatest common denominator, you may have a really big number that you're going to have to work with. Now, looking at this example, I have a 1 in the denominator and a 9. So my least common denominator is not 1 because 9 won't go into 1. However, 1 will go into 9. So 9 is going to be my least common denominator. So I'm going to multiply top and bottom by that 9. So I got 9 times 12 minus 7 over 9. So 9 times 12 gives me 108. And I'm going to subtract the 7, which gives me 101 over 9. You want to see if it reduces. You always want to try that, but nines is made up of threes. And so in order to determine if it reduces, we're going to see if the 101 will reduce by 3. And one way to figure it out is you can say, oh, 101. If I find the sum of it, does it give me a product of 3? And it's 2. So the answer is no. So 3 is not going to reduce this right here. Let me see if I have any more examples to go back and work. And these are applications problems. So I've worked this application problem out in our notes. So check it out. Yeah, I've worked them out. Go check them out.